Thanks for coming to the talk, kind of the survivors making it to the last slot of the conference. So as Kevin said, today I'm talking about Kubernetes. So it's probably a good idea to start by asking how many people here are familiar with Kubernetes? Nice, that's pretty good. How many of you have used it or played around with it, or even something similar like BCOS or Docker Swarm? Not too bad. Is anybody actually running Kubernetes in production? Cool, okay. Better than I expected, so I think this is a good level for this talk. Now, I call this Kubernetes in real life, and I mean a few different things by that. So first of all, I want to focus on running it in production. So this is not about just kind of an intro, what it is, and getting started, but it's about running actual production-grade clusters and production applications. And the second part I mean by in real life is I'm going to be talking about actual companies and their stories in using Kubernetes and getting things into production. And then the third piece is I want to focus on using Kubernetes as it's intended. We can sometimes have this trend in tech where we'll adopt a new technology and kind of pull it into organization and just use it in the same way we were still using our old technology. So if I can use kind of a terrible metaphor for this, imagine you live here in Copenhagen, and for some reason you need to commute every week to Stockholm. And so you drive hundreds of kilometers both ways every week, and you hate it, and it's terrible, and it takes away so many hours of your life. And then miraculously someday somebody comes and they give you a plane. And you're like, cool, this is going to solve all my problems. This is going to make my life so much easier. I'll get so much time back. This is wonderful. And then so the next week, this is you driving to Stockholm. It's probably not the best use of the technology. So this is what I want to focus on using these technologies in the proper way and actually leveraging the features that they have. So my name is Ian Crosby. I'm originally from Canada. I currently live in Amsterdam, where I work for a company called Container Solutions. And we're a professional services company, and we focus around the cloud migration. So what this means is kind of in my day-to-day, I work with different companies who are in the process of moving to the cloud. So maybe they're looking to adopt something like Kubernetes or DCOS, and we kind of help them along this path. And in doing this, kind of I get to see a lot of different situations, but also a lot of the same kind of mistakes and the same best practices that kind of come along in all these situations. And it's in kind of collecting these different stories that I wanted to put this talk together. So I was actually recently at a client, and we were doing a quick kind of proof of concept to show how we could run part of their applications on top of Kubernetes. And as we're kind of going through this proof of concept and building it, I get a lot of kind of the same questions that I get. People who are new to this technology, so they're asking about stuff from where do I store my different configuration files, to how do I handle stateful applications and databases. And as I try to go about answering these questions, apparently I've referred a lot to best practices and kind of Kubernetes and cloud-native best practices. And then on the last day as we were there, one of the DevOps guys comes up to me and was asking, can you point me to these best practices? You know, I looked on the Kubernetes website, I don't really see anything. Where can I find them? And I didn't really have a good answer for that, but I think it's a pretty valid question. And some of the reason why I think this is the case is that, you know, this is kind of a young technology in a young space, and it's also very community-driven. So if we think about best practices, this is stuff we might find on a different blog here or in a different Git repo, but there's not really kind of central location. And this is kind of the inspiration for why I threw this talk together, was I wanted to collect all of my experiences in working with different companies and try and take away some lessons learned there. So at least next time when somebody asks me this question, I can hopefully just point to a YouTube clip of me giving this talk, and then that'll be enough. But I also work with a great group of engineers at Container Solutions who are all doing the similar things. So in kind of sharing our stories, I was able to leverage not just my experiences, but theirs as well. So just a quick outline about what I'm going to be covering today. So I want to start with defining some terms. So what is container orchestration? What do I mean by that? I want to talk about something that I would call the cloud native maturity. And then I want to get into these actual stories of companies that are running Kubernetes in the wild. So I'm going to look at 5 different companies we've worked with and try and pull out some lessons and some best practices. And if you're looking up there and you say, I only see 4, this guy's not really good at counting, kudos for paying attention. But there's one of these, there's kind of a 2-for-1 bonus in there. So then we'll do a wrap-up and try and list some takeaways that hopefully I can leave you with today. So I also just want to quickly outline what this talk is not about. So this is not an argument for moving towards container orchestration. I'm not here to tell you that why this is the best way for your company or organization. It is, but I'm not here to argue that today. I'm also not specifically trying to promote Kubernetes. So there are a variety of different tools out there, such as DCOS I've mentioned, Docker Swarm, Nomad from HashiCorp. These are all really good tools. So if you're new to this space, I would suggest to take a look at a few of them before deciding which one is right for you. This is also not an intro to Kubernetes talk. I think there's really a lot of really good resources out there online if you're just looking to see what Kubernetes is, if you want an intro to the different features and concepts. You can find a lot of stuff online, but I'd like to go a little bit deeper today. Now that being said, I'm going to try not to assume any actual advanced knowledge, so even for those of you who have never used or never heard of Kubernetes, hopefully you can still get some benefit out of this. I'll also be around afterwards, free to talk about any of these things after the talk. So let's start by defining some of these terms. What do I mean when I talk about orchestration or container orchestration? So I pulled this from the Oxford English Dictionary, and they define orchestration as the planning or coordination of the elements of a situation to produce a desired effect. Now, what does that mean in our context? So what are the elements of our situation? Well, we can think of our servers, our applications, we've got some networking, we've probably got some storage. And then what's the desired effect that we're looking for? Well, we want our applications to be running, we want them fault tolerant, we probably want some service discovery so they can communicate, and we want to use our resources efficiently. And the last piece here I find really important, this especially surreptitiously, which I just kind of replaced with the word magic. But what this means for me is that this is things that should happen without any manual intervention, and ideally without me knowing how it's actually happening. So say, for example, I'm responsible for some production system, and it's 2 a.m. and one of my servers explodes. What I'm expecting from my orchestration platform is it's going to detect the failure, it's going to redeploy any applications that were on that node to some other healthy nodes, and it's going to reroute any traffic that's necessary. And all of this should happen without any impact on my end users and without waking me up. This may seem like a lofty ambition, but this is kind of the goal and the ask for container orchestration platforms. These new kind of applications we're building, these kind of cloud-native, microservices, distributed applications, are much too complex to rely on kind of the old-school superhero sysadmin who's just going to get up at 2 a.m. and SSH into a bunch of terminals and figure out the problem. These new systems are much too complex. We need to hand over control to automation and to tooling. So one of these tools, and the one that I'm obviously going to talk about today, is Kubernetes. To give kind of a quick background, I think as most people are aware, it originally came out of Google. So they've been running containers in production for going on 15 years. And they have an internal tool which is called Borg. And based on their lessons learned and what they've been doing, they created this new project, open sourced it, and called it Kubernetes. And since then, it's been actually donated to the Cloud Native Computing Foundation. So there's no longer one single company behind it. And it's grown really fast in adoption. I think part of this is because of the community that is behind it. It's moving really quickly. Features get added to it at a pretty good pace. And if you're looking for resources, looking for help, there's lots of resources out there. So this all sounds great, We can kind of leverage all of the lessons learned and all of the heartache that Google's gone running at their scale, take this, install our applications on it, and we're done. But obviously, this is not that simple. However, we often get contacted from different companies who give some kind of message along the line of, hey, we hear that you guys are Kubernetes experts. Could you come over to our office and set up a cluster? And as you start talking to these guys and asking, about their current technology stack, what are their current processes, more often than not, what we find out is, maybe they have some giant monolith application, and they're deploying this thing to production twice a year. So sure, I could go over there and I could set up a cluster for them and maybe even install their giant monolith application. But then we're kind of back to this, driving the plane to Stockholm kind of thing. This isn't the best fit. And not only are they not going to be able to leverage the benefits, they're probably going to be worse off than they were. So really, you need to be, first of all, kind of in the right stage to adopt these new technologies. The next thing that's important is your motivation. So a lot of times also, we talk to managers who complain about not being able to attract and retain talent because the technology they're using is a little bit outdated, so none of the new developers want to work there, and the existing developers complain about this stuff and want to work with the latest, coolest stuff. So they decide, okay, we're going to go and get Kubernetes. Or maybe there's a manager who doesn't understand why it takes 2 weeks to deploy their application, when in fact they've got their ops team sitting in one office and the developer team sitting in another office, and they think the solution is just to go and get the latest, coolest technology that they saw in Hacker News. So, it's obviously, the technology is not going to solve these kind of organizational problems. You need to look at kind of your processes and ensure that you're ready for these technologies. So we've gone through this kind of process with quite a few companies, and we've developed what we call the Cloud Native Maturity Matrix. So there's a lot going on this slide, but the important piece is that we basically identified 8 different pieces of an organization. So everything from your infrastructure to your team structure to culture, and then tried to list out the different kind of maturity levels, from the more legacy to the more bleeding edge. And we use this to, on the one hand, identify where a company sits. So in terms of maturity, where they are in each level. And in this way, we can kind of help identify and show them where they can best leverage, where they can best gain effort from putting their resources. What's important to note here is that you really want to move all of these columns or all of these rows at about the same rate. So for example, what's the point of moving to microservices architecture if my application is all running on one single node in my server closet? But assuming you do have the right pieces in place, you have adopted automation, you have CI, you have CD, and you are in the right step to move to orchestration, how do we get there? We've decided on the technology, we've looked at a few, we decided we want to go for Kubernetes. And what are the steps that we need to take to actually take this to production to start leveraging from the benefits? And I think one of the best ways is to look by example. So that's why I want to look at these specific companies that we've worked with and try and take away some examples of how we get there. So as I mentioned, these stories are true, actual companies we've worked with. I have anonymized the names to protect both the innocent and the guilty. So the first question that you necessarily come up to is, where are we going to run this? And the kind of traditional answers are, well, on-premise or in the cloud. But with these new technologies, there's a lot of gray area in between. So yes, we could run this on our existing infrastructure, fully manage our own clusters, or maybe we run it in-house, but we use something like OpenShift, so we get a certain level of support and we get a certain level of comfort. Or maybe we run it in the cloud and we leverage a full kind of SaaS solution, something like Google Container Engine or Azure Container Service. Or we could decide to run in the cloud and manage it ourselves. So depending on which solution you choose is going to depend on your requirements and your specific use cases. I'm going to look at 2 different companies that I worked with this year, 2 quite different companies, and the different scenarios that they ended up with. So this first company is it's a startup in Amsterdam. And as startups do, they were leveraging kind of using all the newest technology. So everything was microservices, everything in Docker containers, Kafka, Elasticsearch, all this cool stuff. But when we looked at what their actual business needs were, and they needed to get their platform live in advance of any of their competitors. They also wanted to grow their team and grow their application, so adding features. So that means that they don't want to waste resources to manage their actual infrastructure. And they don't want to waste time in trying to learn new technologies. So in this situation, we went with Google Container Engine because it allowed them to get clusters up and running in just a couple of minutes. You have somebody else who can manage this stuff for you and let the teams and let the developers actually focus on just writing code. So as a result of this, they were actually able to go live on time, and really they've since doubled their actual development team. And one of the kind of the claims that the CTO likes to make is that every developer that comes on board has pushed code to production within 2 days. Now this is something that's not possible if a developer coming online needs to not just learn the application, but needs to learn about Docker, needs to learn what this Kubernetes thing is, and how they all fit together. So by having this kind of SaaS platform and building an abstraction layer on top of it, the developers don't need to learn about all these things. They can just focus on adding feature and adding value to the products. Additionally, they were able to do this with just one ops guy working part-time. So this is an example of really kind of moving in the cloud-native way, so leveraging this new technology so you can just focus on your actual business. Now, on the other end of the spectrum, I worked with this company also this year who, they were kind of under a government umbrella and had some pretty strict security concerns. So, they had some very different requirements. Specifically, they had to host all their own stuff. In addition, they were running everything on a closed internal network. So it's kind of tricky to be a cloud native when you're not actually connected to the cloud. But the team here was actually still quite motivated, and they still wanted to adopt new technologies. So they had gone to some conferences and saw, okay, Kubernetes is awesome. This is really going to help us move forward, so we're going to install this. And they went back, and they started working on it and trying to get it installed. Ran into some issues, and they started kind of looking for help. So we went and worked with them. And as I kind of asking how they went about, installing this Kubernetes on these internal networks, they kind of reluctantly admitted that, well, basically they had a USB stick, and they would go to a laptop that was connected to the internet, download whichever binaries seemed to be in the last error message they saw, bring this over to their secure internal network, plug it in, copy the binaries, and repeat the process. Now, these were smart guys, and they realized that this was not the best way to go about things. But they were just trying to work around the restrictions that they had. There was these kind of security guidelines which had probably been around for 10, 20 years that weren't really up to date. And so these guys were just trying to get things done. But the result of this is that, they end up with a much less secure system, because who knows what kind of files they were moving back and forth. And also, they're wasting a lot of the developers' time, just copying binaries and Docker images around. So I think the lesson here is that in moving to kind of this cloud-native space, it's not just about taking a new technology. You have to look from an organizational perspective. You have to review things like your security policies. Do these still make sense in this kind of world? So the next question that you generally run into, once you decide where you're going to run your clusters, is, well, how many clusters do I need? And how am I going to manage my different environments? Do I need to run my applications on different clusters? So I definitely need one for production. And then we have a staging environment, so I'm going to want to put a cluster there because we want to mimic production. And we'll probably want one for test. And then what about the different dev environments and all of these things? So this is a challenge that we ran into with another company we were working with. And this is another company in the Netherlands, and they have an online weather service. And the weather is something very serious in the Netherlands. If you ever go to Amsterdam and you'd like to make friends with a Dutchman, just make some offhand comment about the weather, and for the next 5 minutes, you guys will be best friends. So these guys had a very important service that they were running. And they were looking to adopt orchestration. Now, like any good weather service, they were obviously already running in the cloud. Sorry. But their AWS bills were something they were concerned about, and they saw that the resource utilization was pretty low. So they thought by using orchestration, they could kind of bring these costs down, which makes sense, basically. But then as we started looking at, the clusters and how big the cluster size was, and then they thought about all the different environments they had, they started getting concerned that their bills were actually going to go up. So we worked with them to kind of come up with a different solution for this. Because, just because in your old way of doing things, you had all these different environments that were up and running 24/7, maybe that doesn't make sense. Maybe you can leverage the new technology to do things a bit smarter. So we set up something with Kubernetes by leveraging the different features. So essentially what we want to do is share the underlying resources. So we start with one single cluster, and we use a basic concept called namespaces. And namespaces is basically a subcluster within your cluster. So for example here, we set up a namespace called staging. And then all the applications you deploy to staging can communicate with each other. And then you create another namespace called dev, for example. And then all those applications can communicate with each other. So this way, you're still using the same underlying servers, underlying VMs, but you can kind of share the resources. But it turns out these things are really easy to create and actually remove. So do we really need these things up all the time? We can actually just integrate this with the actual CI pipeline so that you run your build, you do your tests, and then you deploy this image to a new namespace that you create on the fly. You add any dependencies, and then you run your integration tests in this virtual cluster. And then once the tests finish, if everything's okay, you just completely delete it. So you can create this kind of new kind of workflow. Then you kind of get maybe these concerns around access. And, well, maybe I don't want my developers to actually be able to accidentally delete everything on staging or on prod. So we have another feature in Kubernetes called RBAC, or role-based access control. And this allows you to give specific roles or specific access to your users. For example, you can say developers have full access to everything on those dev environments, but maybe don't give them access to staging. And you can go a step further and add something called network policies. So now we can actually limit the applications themselves and who they can talk to. So we can ensure that everything running in staging is not able to communicate with anything outside. And these are quite flexible. You can do it by an entire namespace or just by certain applications. You can control ingress, egress, or bidirectional traffic. And if you want to go even further, we can add full service-to-service level TLS. So this is, for something like this, we would use something like Istio added on top. And this way we can ensure that all communication between our services is secure. So the lesson here is that we can leverage the features of these new technologies to solve our old problems, but in a smarter way. So we've decided where we're going to run our clusters. We've configured our different environments, and we've set things up around security. So the next thing we want to do is actually deploy our applications. And this is where Kubernetes can really shine. If, for example, your applications are already in containers, for example, then running things is really simple. With this one really short command, I now have my application up and running in a fault-tolerant manner on the cluster. So when I do this, there's a whole lot of things that happen behind the scenes. For example, Kubernetes is going to find a node that has the sufficient amount of resources for my application. It's going to schedule the application on that node. It's going to create a pod on that node, which is the concept in which it runs applications. It's going to create a container network inside that pod. It's then going to go into the default registry, fetch my image, bring it down, and run it. It's also going to create a deployment, so it'll ensure that my application always stays running. If it crashes, it'll restart, and ensure that the right number of instances are running. So this is a lot going on behind a very simple command. And for me, this is kind of the double-edged sword of Kubernetes. you're abstracting away a whole lot of things. I'm specifying here one command, run, specifying the image I have, my Docker image, my app, and I'm just giving it a name. And then behind the scenes, there's at least 100 or 200 different configuration items that are either inferred or set to defaults. And this can come to kind of bite you in the ass. So this next company that we were working with, again, this was kind of a governmental branch, so think large enterprisey processes. So they had adopted Kubernetes and were kind of in a proof of concept stage to showing that it would be valid to run this in production. And they were having issues where certain nodes were running out of memory. And as they were running out of memory, and then certain applications were getting killed, and they couldn't really figure out why. So we were working with them to try and debug these things and figure out what was going on. And the first thing to note was that these were all Java applications running in containers. And they were specifying kind of the heap size and how much memory each of them should use. So essentially they were taking these old Java applications that they had been running before on their separate servers and just running them the same way inside a container on Kubernetes. And the problem here is that there's some very important settings which you should be using on all of your applications. And this is to do with resource limits and resource requests. And it provides a similar thing to this, to the kind of Java memory arguments. But basically you're saying how much CPU and how much memory my application needs, and what's the maximum that it should get. So without setting these, essentially it was reverting to some defaults. The applications in the containers just saw that they had access to everything on the node, and then maybe there was something problem with the application, but essentially it was using all the memory, and then the killer would come out and just randomly start killing things. So if you set these actual settings, then it creates what's called a quality of service in Kubernetes. So based on how you set them, you'll end up with different tiers of applications, either guaranteed, burstable, or best effort. And basically what this does is it allows you to triage or prioritize your applications so that if you do start to overcommit and you get into these memory problems, it'll be the best effort ones that are going to get killed first. So this way you can identify your critical applications, ensure they get a guaranteed QoS, and that they'll stay around running. So I think the lesson here is that you need to learn about the actual applications you're using, or the actual tools. You don't want to just take your existing applications and run them in the same way now on this new technology. You need to understand the technology and the settings that are there. So the last case that I want to talk about is around monitoring. And I think this is kind of appropriate because, in my experience, monitoring is kind of the last thing we seem to think about, where it's, okay, we're about ready to go to production. Oh crap, we forgot about monitoring, get something in place. And I think part of this has to do with the fact that monitoring used to be a lot simpler in kind of the legacy systems. If you have some giant monolith application, we do what I like to call the poke it with a stick monitoring, just kind of like, is it alive? Yeah, okay, we're fine. But in running these new complex systems, monitoring has become not just a lot more important, but a lot more complex. There's a lot more pieces involved. We might have hundreds of services running across dozens of different nodes across multiple regions. In this situation, if some container dies on this VM over there, do I care? Maybe. It depends. It depends on the higher context. So I don't want to know about these specific instances of a container dying. I want to know, on a higher level, how's my service reacting? So again, we can't just take these existing monitoring systems we might have had for our legacy applications and just patch them on to our new systems. So I had this project where this was a company that was about to go live with their application. And they had this kind of problem, like, oh crap, our existing monitoring is just not going to work. So we needed to find a new solution. And again, there's different decisions that you need to make here. For example, do you build and host your own, or do you use something along a SaaS solution? So if you are going to run your own application, your own monitoring system, there are some really great tools out there, something like Prometheus, which really focuses in this kind of cloud-native distributed monitoring. Or if you need to go for a SaaS solution, there are a lot of SaaS products out there that do have these cloud-native microservice concepts. So in this specific case, due to kind of time constraints and the time that I'm already there for production, we ended up going with one of these SaaS providers. So you need to find one that does have these concepts of these tools that you're using. So a lot of them will have maybe a Docker integration or Kubernetes integration. And so within just kind of a couple days, we were able to get very pretty graphs, which all the program manager people type really like to look at. But more importantly, we're able to get kind of this higher level view of our application. So it's not just saying that one specific container might have died, but we get a better idea of the health of our system. So the main takeaways that I want to kind of leave you with today is that container orchestration is the future. It is kind of the way forward. If we want to move into this cloud-native space, orchestration is going to happen either manually, or you need one of these kind of tools to take care of it for you. That being said, you need to be ready to adopt it, right? If you're still doing things manually, if you don't have proper continuous integration in place, then it's probably too soon for this, and you need to work on these things first. And cloud native is not just about the tools. It takes a lot more. It's about your entire organization. You need to buy in and look at things like your processes, look at your security guidelines, and ensure that you have buy-in from the whole company, not just one team that wants to adopt some certain tools. You also need to leverage the technology, so understand how it works and what are the features that it offers you so you can really take advantage of all the features that it has. And generally, it's about using these tools in the right way. Just as, because we have Jenkins installed doesn't mean we're necessarily doing continuous integration. Just because you have Kubernetes doesn't mean that you're cloud native. Thanks.
Thank you. And I think we have some questions in the in the app as well. For example, somebody is asking about running different namespaces in terms of noisy and scaling up. Can you maybe elaborate more on that in terms of how do you actually think about that when you're running with namespaces instead of spinning up new environments? What have companies done for that in terms of, yeah?
So in terms of kind of, because it can be very easy to spin up, you can kind of go a little out of control. So you do want to have processes involved. So for example, I worked with a company who wanted to spin up kind of these new environments for each of their feature branches. And so we built in that each feature branch is built, they create a namespace, deploy it, run the automated tests, and then completely clean it up. But sometimes there are cases where you want to leave this around and maybe do some manual testing or maybe just show off the feature. So we also needed to add something where essentially we would look at kind of essentially a cron job that would go and see which namespaces are actually being used, which is in this case where proper monitoring comes into play to seeing which pieces are being used, and that way you can actually have proper cleanup. Otherwise it can get kind of out of control.
Cool. Can you maybe go back to that maturity model you had? Because there are some questions about all the different products, Ansible, Chef, and because the question is Kubernetes basically for us? And I think maybe you could elaborate more on that. Like, what does it take to move to Kubernetes? And if you're already set out on Ansible, is it worthwhile going to Kubernetes?
Yeah, so the important thing that I wanted to highlight here was that you want to move kind of everything along at a similar pace. So you want to ensure that you have your processes kind of move forward as well as your architecture and your infrastructure. So specifically stuff like continuous integration has to be in place before you can adopt some kind of orchestration. Generally, you need to have fully adopted automation kind of everywhere. So the question around, is there benefit going from Ansible to Kubernetes? I think definitely. So Ansible, in my experience, is more about just setting up your actual infrastructure. So you can also use it to kind of handle deployments, but it's not going to give you these other features like service discovery, like communication, like fault tolerance if my applications are running, or if they failed, are they going to get rescheduled? It's not really built for that kind of thing. So I think having a platform like Kubernetes is a natural extension or a next step.
I think there's also something about the whole cloud-native computing foundation. Could you maybe elaborate more on that in terms of, because they have already chosen a set of tools, and how have you seen maybe these get adopted in the companies that you've been working with, comparing to the choice that Cloud Native Computing Foundation has chosen?
Yeah, so the Cloud Native Computing Foundation, it's a branch under the Linux Foundation. Yeah, and they kind of adopt these set of tools. So Kubernetes was the first one. I think now there's at least a dozen: Prometheus, Linkerd, Jaeger, a bunch of stuff. And I think this does offer a certain sense of security, or companies are more likely to adopt these things when they see this kind of brand or badge tag to it. Whether that's relevant or not is maybe a discussion for over a beer rather than here. Don't want to get in trouble. But it does offer some sense of legitimacy, and they do, for example, have rules around it must be open source, which I think is obviously a good thing.
But how have you seen the adoption in the companies that you've been working with? Is that something that have been taking in and saying, yeah, there was a good choice?
So companies adopting those technologies and, yeah, well, so yeah, I guess I could say that I have yet to see a case where, yeah, maybe a company adopted these technologies and said, no, this is crap. Why is this under the CNCF? But it's early days.
Yeah, so you would recommend using many of the things that the CNCD.
Yeah, so the ones that I'm familiar with, for example, Kubernetes and Prometheus, I think are great tools. Some others I've worked a little less with, but generally they have pretty good guidelines in terms of adopting technology, I think.
Okay, I think that was mostly it. Then there's also some questions about some really specific ones, and I think maybe you can ask Ian about that, as in terms of some of the limits and requirements in terms of CPU. But go and ask that yourself. That would be really good. Other than that, really thanks for the presentation, and give me a hand.
Thanks.